Hey, what's up? Nathan here from PH Studios. Welcome back to another XNA tutorial. And in this tutorial, I'm going to discuss pixel shaders. As I mentioned in a previous video, I would do this tutorial. This sample, well, a pixel shader sample, has been available to premium members for a long time now. But I'll finally release it to everybody else. And I needed to upgrade it to XNA 4.0 because they did different things. And I really didn't want to update the entire code. What I did for the premium members sample is I took my space shooter game and made a effect that when a player or enemy gets hit, that it'll just do this hit effect on that specific object. So it would have been a lot more complex to upgrade that project to XNA 4.0 and upgrade the way the pixel shaders work in, well, the effects work in XNA 4.0. So I'll just do this small sample and give it to you to mess around with. Alright, so before we go into the coding, let's discuss what a pixel shader is. A pixel shader is a language that you use to manipulate every single pixel of a texture. This is usually done, the coding is usually performed on the graphics processing unit, your graphics card. So it is very fast by manipulating every single pixel in a texture that you provide. If you watch my per pixel collision, I mentioned that looking at every single pixel is a lot of time consuming work that the computer needs to do. Well, the graphics processing unit is much faster at doing things like that. So you do not see any downtime by manipulating every single pixel of a texture when you're inside of the pixel shader code, because it is performed on the GPU. Now, Vertex Shaders, I only mess with those once. Those are manipulations of the vertices of the object. Something like that. I'm not that familiar with it. I'm sure somebody out there watching this video can comment if you're interested and let us know what a Vertex Shader does in great detail. Again, I only used it once, and I just used a sample code, so I didn't really think that much about it. I'm more interested in the pixel shader than the vertex shaders. They're probably more useful when you get to 3D development, but since I'm working on mostly 2D, I really don't have a need for it. Alright, so this tutorial is about pixel shaders, so let's work on that. So, inside of your Solution Explorer, if you right-click the Content subproject and go to Add, and you should see New Item. This is outside of the recording window, but there should be a new item there. Once you click that, you will have an effect file that you can create. So you just name it and click Create. Now, I always delete everything. It gives you a vertex shader. Let me go ahead and add it. Add new item. It gives you a vertex shader, and yeah, you use the position of the object instead of the pixels. So I usually delete everything so I can just code it from scratch and not use a vertex shader. I just want to use a pixel shader. So I'm going to go ahead and delete this file, and let's look at the one I already created. Alright, so I created just a pixel shader function and the technique and pass. Alright, so what this pixel shader does, and you can use this in your project, you can manipulate it if you want to, but what this code does is it manipulates every single pixel, the color of every single pixel inside of the texture here. It manipulates that to have a grayscale version of that color. So I just convert the texture to a grayscale image. And a very simple technique to do that. You just use a dot product and you dot the RGB color by 0.7, 0.59, and 0.11. Now multiply this by a percentage, because like I said, this was a hit effect. So if you get hit, it's gonna flash in grayscale and notifying you that you get hit. So you can leave this percentage value if you want to. If you just want a grayscale permanently, you can just delete this percentage value and just use it permanently. But anyway, I get the color of that texture. Now this function has a parameter. It's a float2 and it's called text. And what this is, it's the texture coordinates for that specific color we are looking at. And we are returning a color value right here. Now what we need to do is we need to get the RGB values for that color. So we need to look at that texture and use the coordinates of the text of the pixel we are looking at. So we gather the color values. It's in a float, so we gather the RGB data from the texture we're trying to convert. So RGB, and then we convert the RGB. We store the old ones, and then we convert the new ones to have the grayscale representation of that color. Now, that's only half the problem. What I wanted to do with these lines here, if we remove those lines, it would go to grayscale, but it would fade to black, and then our image would restore. What I wanted to do is I wanted to go to grayscale but fade to the original colors. So what I had to do is I gathered the old R and subtracted the difference between the new RGB value and multiplied by the percentage. Now I did the same thing with G and B. So RGB, take those values, the old ones, minus the difference between the old and the new, and multiply it by the percentage. Then I set the color.rgb to the updated colors. And then I just return the color. So, when you're trying to develop a pixel shader, you have to think about objects, images, textures in a completely different way. You have to think of it both in great detail and not in great detail. You need to think of how you can manipulate every single pixel at once, and you need to think about how not to worry about what each pixel is. So basically, how can I convert every single pixel to the color, the grayscale color representation? And it's a pretty simple technique. I just get the current color of that coordinate and then convert it to the grayscale representation. And I took it a step further by only calculating it by the difference between the new grayscale representation and the old color, and then multiplied it by the percentage value. Okay, and the technique hit and pass one. This is just the start. You can have multiple passes, and then we notify that we have a pixel shader and we need to compile it. This is using Pixel Shader 2.0, and call the function that we named it up here. Okay, so that is the pixel shader. Now let's look at the game1.cs file. Okay, now I have two objects, a player and an enemy, and I have a background texture. What I'm going to do is I'm going to simulate a hit, and I'm going to take this a step further by manipulating both the player and the background. During this video, I'll change it to where you can see only the player will be manipulated. But for the first run of the code, both the player and the background will be manipulated by this pixel shader, and the enemy will stay the same color. Keyboard state, so we can move the player around and simulate that the player is hit. The effect object that we want to call it, and the float percentage value that we want to present the grayscale effect. Make it 720p resolution, load the content, or initialize the content. So initialize player, enemy, and their positions, and start the keyboard state objects to a new keyboard state. And load content, you've seen this before except for the content.load effect. The hit.fx file here is an effect object. So instead of content.load texture 2D, we have content.load effect. And then we set the percentage to 0. Unload content, just dispose of the two textures. Alright, update. The same thing you've seen before, the keyboard states need to be updated. Set the speed of the object we want it to move, and the percent scale, what we want to decrease the percent by every loop. So if the percent is greater than 0, we need to decrease the percent by the percent scale we have up here. Now we have a effect object called G-scale effect. So what we need to do is we need to set that percentage parameter right here inside of that FX file, that float percentage value. We need to set that to the appropriate percentage. So in order to get to that, you need to have the effect object dot parameters, and the parameter name, in this case it's percentage, dot set value and the value you want it to be. And that's going to be changed every time this code updates, because we need to decrease the percentage and set it again. Okay, a movement vector to determine our sprite, our player. Move up, down, left, and right. You've seen this code many times before. Just apply the speed to the movement vector, and then finally we're going to set the velocity to that movement vector, and then update the player and update the enemy. Now, to simulate that the player is being hit, we need to map that to the space key. So if percentage is less than 0, we set it to 1. We do this because we do not want to press the space key quickly and get a effect just restarting. We want it to only allow the space key to restart the effect when it's completely done. And I'll demonstrate that when we run the code. Okay, so now to demonstrate what this is going to be doing is I use that enemy player, the enemy object. I'm using that as a demonstration on what can be manipulated by this pixel shader and what cannot. So, if we have the pixel shader, if we simulated that the enemy has been hit, so the pixel shader is going, it's processing the information. We need to apply that pixel shader, so we use this long begin code, 0, null, 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 and then G-scale effect. So we need to pass it the effect file. So now anything between the begin and end sections will be manipulated by that pixel shader. So both the background right there and the player will be affected by this grayscale effect. So if I want other objects to not be influenced by this pixel shader, I have to create another begin and end cycle that does not have that effect object, and it's just a standard begin and end call you've seen multiple times. So the enemy will never be influenced by this pixel shader because it's in a completely separate sprite batch begin and end cycle. Alright, so let me press F5 and run the code, and I'll show you the result. Okay, so now you have the enemy, which is a greenish, orangish, weird color. And you have the player, which is just your standard blue spaceship that you've seen in all the other samples. And you can move it around. I didn't do any bounds checking because this is just a quick sample. Now, if I press the space key, it's going to simulate that the player has been hit. And we want that hit effect to fade the screen to a grayscale. You can make it fade to a red. You know how some games do that. Some games have like the borders of the game flash red or something like that. You've seen those in some games before. So if I press the space key, it's going to manipulate the entire background and the player. And that's a pixel shader, so I can move and it'll still have it manipulated. And if I press the space key really fast, it'll only do it whenever it's completely finished. Okay, so now, to demonstrate, I want to remove that background from the grayscale effect. So I just want to manipulate the player object. So I need to create another sprite batch.begin cycle because the background needs to be below every object. So sprite batch.begin, sprite batch.end, and paste that background. Alright, so now just the player object will be affected. So that's a really quick introduction to pixel shaders. Remember to think of textures as a pixel by pixel basis, but don't go farther in depth by confusing yourself. Just think of how you can manipulate every single pixel individually, but you want to have the same result. So if you want to use this grayscale effect, you're welcome to. You can change these values around. Like, I want the blue to stand out more, so I'm going to decrease that percentage value to about 0.1. Now if I use that, it'll be a lot more blue than it was before. Or 0.9, depends which way you want to do it. It'll be brighter blue. It'll be more white. And I can go 0.9, 0.9, 0.9 and see what that looks like. That's pure white. So 0.7, 0.59, and 0.11 seems to be the standard for graphics. I think I manipulated these just a little bit, but I'm not completely sure. I'm sure if you Googled how to convert a color to grayscale, it'll give you some of these values. I think it was 0.65, 0.59, and 0.11. I think I increased the red. So if you want to make it a little bit brighter, you just increase these values just a little bit. 0.5, 0.7, and 0.2. Makes it a little bit more white in there. And there you go. That's a pixel shader. So I hope you enjoyed this tutorial. You will have this sample available to download. And just play around with the pixel shader. Think of ways that you can manipulate the pixels. And if you come up with something cool, let us know and we'll see what it looks like. XNA 4.0 does make this a lot easier to use the effect files. Much easier to use pixel shaders because all you need to do is one begin call that looks like this, and anything you want to be affected, anything you want the pixel shader to effect, you want it in between those begin and end cycles. Now you can have multiple effects if you want to. You just have another one and change the effect that you wanted to use and change the objects you wanted to change. Alright, so I really hope you enjoyed this tutorial. There will be another tutorial sometime tomorrow. I hope to see you then.